As a young bloke, John used to ride his push bike out to West Subiaco Aerodrome, where Herman Eddershagen had a Clem and a few other aircraft. Later, he rode his bike all the way out to Maylands and used to hang over the fence there. He used to throw himself with vigour into any job that he could get, pumping fuel, and every now and then he'd hitch a ride in a Tiger Moth. John studied at university, and one of his jobs was working at the Commonwealth Aircraft Corporation, doing research and working on the Rolls-Royce main engine. He went to England after graduating and worked with English Electric. In 1957 he returned to Australia and became a lecturer at UWA in mechanical engineering. John's interest in things mechanical is very, very wide and varied, and he's going to talk today about Charles Redrup. I'm sure there'll be some surprises here for you.
I'm going to start this presentation by seeking a show of hands. If, before you came to this meeting, you had any idea at all who Charles Benjamin Redrup was, would you raise your right hand? That's not really surprising, although there's one man here who has some inside knowledge. Not really surprising, because what I'm going to show you is that Charles Benjamin Redrup was an amazing designer of aircraft engines and also a prototype manufacturer. He had great skills indeed, but he was a very modest man, too modest. He was always in the background. I had no idea of him until the tail end of last year, when a colleague of mine from the UK was visiting Perth and presented me with a copy of the book that you see on the screen. Well, after he'd left and I farewelled him, I opened the book, and with the very first chapter I was interested, and as I read on I was enthralled, so much that I made a draft PowerPoint sequence of some of the photographs and images in the book. And I showed this PowerPoint to Brian Hernan, and also lent him the book. And he too, I believe, when he read the first chapter, became as interested as I was. Brian has helped me tidy up and certainly improve this slideshow, but I hope with the slideshow's assistance I can introduce you all to Charles Redrup. Now, it's likely to be a mechanical engineering address, and for mechanical engineers in the audience, you'd probably revel in some of the comments here. Some of you, perhaps the ladies, might find mechanical engineering details just a little bit much. If that's the case, then just think about Charles Redrup as a human and what he's achieved in his amazing life. He was born in Wales, 1878. But the interesting was that he experienced the dawn of motorcar automobile engineering. As a young lad, motorcar engineering was just developing. At age 7, he was enthralled with the harbour and the docks in Barry, the port of Barry, plus the ships and the railways. Also, at age 7, he had started experimenting, and unfortunately, in an accident where he was endeavouring to experiment with steam and furnaces, there was an accident and he lost the sight of his left eye. It's useful that you know this in advance, because all of that which he accomplished in later years was done with the use of one eye. At age 14, he was apprenticed to the Great Western Railway, and what a magnificent apprenticeship he got in those 5 years. Drawing, pattern making, foundry work, machining, assembly. He was also, as an apprentice, taken on a maintenance tour to visit installations of the GWR, a great background. At age 15, his father was able to provide for him his own house and, relevantly, his own workshop. Now, a workshop sounds very magnificent, but this was really a backyard shed in which he had a lathe, a milling machine, a grinding machine, but he also had acquired the ability not only to design engines, but to produce with his own hands prototypes, working prototypes. At age 19, he was signed on as assistant to the chief engineer on a cargo ship going across the Atlantic to Philadelphia. This was quite an interesting voyage, but not so interesting for him. The ship faced a force 10 gale, and in that force 10 gale, the props came out of the water. The engines raced, the safety valve blew, and the boilers went out. So he and the engineering crew had the task of reigniting the boilers in that pitching sea. When he got to the US coast, the ship only stayed half a day and turned round and came back. So as a result of all this, he lost any interest in going to sea. At age 20, he worked for Richard Stevens, who by that time could be labelled as a car manufacturer. Stevens built the first car designed and built in England, and I'll show you later a photograph of a restoration. At age 23, Redrup designed and built an engine for a bicycle with a shaft drive, shades of BMW in later years. And at age 24, he set up the Barry Motor Company and designed and built a supercharged rotary engine. All of these, if you think about it, are looking well into what was the future. At age 31, he held a patent for internal combustion engines with sleeve valves. But relevantly for us here today, he was present at the birth of Aero engine design. So we could say that in his life he was an outstanding mechanical engineer. He had a lifetime of design of internal combustion engines. He was a competent precision machinist in his own workshop. Rare qualities. A lot of people might design but not be able to construct. He had both abilities. But he was unassuming. He was an unassuming perfectionist. Usually perfectionists are rather dogmatic folk. He was rather the contrary. Over his lifetime, others have taken the accolades for events into which he was really a major contributor. He didn't make the headlines, but he did make significant contributions. This shows the Stevens motor car. Stevens was originally a bicycle manufacturer, and his design was really the coalescing of two bicycle frames. This shows the restored Stevens car, and if you look carefully, you'll see that it has independent front suspension. Redrup was hired by Stevens not only to improve design, but it was also hired to drive people around the local town. In 1908, Redrup was very well aware of the first controlled powered flight in England at Farnborough, as we all know, by an American-born Franklin Cowdery, also known as Cody. And this shows Cody looking very handsome with a moustache. But Redrup motorcycles over the years, this is one of the early designs. This was a rotary engine. This was a radial engine. And in the 1940s, this was one of his later designs of a rotary. But I think one of his greatest inventions was the reactionless aircraft engine. We all know that in World War II, most, if not many aircraft, had the rotary engine, where the crankshaft was stationary, the crankshaft and the cylinders rotated with a propeller attached. The design had two objectives: to use the mass of the rotating parts as a flywheel, and also under the illusion, as it turned out, that succeeding cylinders would get more cooling effect. But the big problem, as unfortunately many pilots during World War I discovered, was that the mass of the rotating engine was like a flying gyroscope. And so aerobatics, for some of them, proved rather fatal. Certainly interesting. But Redrup decided, why not have the crankshaft rotate and also the cylinder and crankcase rotate in the opposite direction? So we had counter-rotating propellers. And if you see, this is part of one of his earlier experiments, you can see the extra mass that he's put on the crankshaft blade to counterbalance the mass that was rotating on this, albeit single cylinder, for the other propeller. And in 1917, from a demonstration, he was able to show that his reactionless engine had no overall gyroscopic effect. And here he is, this is a drawing, but here he is showing that he could sit on an imaginary chair with that engine giving smooth rotation. But he was also a researcher. And this shows what I think was one of his major breakthroughs. He thought about the rotary engine and that second so-called advantage of the rotary engine, the idea that successive cylinders would be better cooled by rotating as the aircraft flew. He wasn't so sure about this. And this graph shows a very painstaking experiment that he conducted. It shows the number of fins on a standard cylinder and also the heat transfer, depending on the number of fins. So he starts off here, not surprisingly, with 1, and he gets right up here to number 49. And in each case, he ran the experiment, checked the cooling rate, and found somewhere near an optimum. Obviously, when you're well up here, where you have, 49 fins on one cylinder, the machining is rather a task. To complete those series of experiments, he had to machine 1,275 fins. So you can imagine how patient he had to be. As a result of this, he decided rotary engines were not for him, and he founded the Hart Engine Company. There's a sketch of him a little later in life. But the Hart Engine Company designed and manufactured the Hart Radial, and you can see there the multi-fin cylinders that we've come to know on radial engines as standard. In 1914, his Hart Engine Company was absorbed by Vickers, and the Vickers FD-12B prototype, the gunship, was designed using one of his engines, his Hart engine, as a pusher. The idea of this was to be a gunship so that the gunner had a clear view ahead. But this photograph, I think, is interesting because it's one of the few that shows the young Redrup in a very modest pose. He was always in the background. This shows a very modernistic aircraft that is difficult to trace, but it shows the Hart engine with a very streamlined cowling design. 1918, the Hart Engine Company was dissolved and Redrup left Vickers, and Redrup started designing an axial piston engine. Normally, a cylinder is going up and down and the crankshaft is going round and round, but with an axial piston, the piston goes backwards and forwards, and that motion is translated into rotary motion for the crankshaft. How, you might ask? Well, by the use of what's called a wobble plate. And the best way to understand how the wobble plate works is to show you this one in action. As the pistons go back and forth, the wobble plate does not rotate, but its spider arms translate the axial motion into rotary motion on the crankshaft. And just the designing and machining of the wobble plate drive crankshaft is interesting. A Z-shaped crankshaft. These are the counterweights. And obviously with the wobble plate not rotating, it needs significant bearing. This is another concept for axial drives. This is a swash plate. In this case, the crankshaft is straight and the swash plate is attached to the crankshaft. But the reciprocating pistons still provide that rotary drive. Redrup developed the axial piston for a marine engine. And this shows a cross section. It's got a wobble plate with the usual Z crankshaft and heavy bearings. And as the pistons move back and forth, so torque is provided to the crankshaft and the tail shaft. This shows the relatively compact marine engine, and this one shows that it works. There's Redrup again, sitting in the front and proceeding at a very sedate 6 knots or so. In 1925, Redrup joined Crosley Brothers and designed a 9-cylinder axial engine for a bus. This wobble plate is certainly a massive thing, but the beauty of it was that it was low slung. As you see there, quite compact. In 1925, Redrup was invited to join Aero and Company. Now, everybody's heard of Aero, but very few people, including us, haven't heard much about Redrup. But Redrup was designing for Avro. He had the Alpha engine, a radial engine with his close-finned design, and this is the Aero 504K. Just note on this image the World War II 14-18 landing gear with the ski type forward end. The 504K was later fitted with this hydraulic undercarriage. It was designed by a 19-year-old Aero employee with the name of George Doughty. Now, those of us who were looking during the 1940s and the 1950s at magazines like Flight and the Aeroplane couldn't fail to remember advertisements for landing gear, hydraulic undercarriage, designed by the name Doughty. Well, Redrup was there and Doughty was an apprentice. And here it is. The pilot of this aircraft had successfully flown this machine in competitions in the Lancashire Flying Club. This was 1926, and the pilot was very keen to develop in Manchester a suitable airfield landing strip, centre of aviation. And he thought that such a machine with such power should gain attention in the press if he was able to land it on top of Helvellyn. Is anyone here from Lancashire? Anyone been to Lancashire? Helvellyn, oh, good lad. Helvellyn is not the highest, but it's close to being the highest mountain in the Lakes District in Lancashire. And Leeming, as his name was, thought it would be good publicity if he could land and take off again. We've all seen, thanks to Brian's clip a little while ago, an STOL that was dramatic. But I think perhaps the very first, not STOL, but SLTO, safe landing, and let's hope a safe takeoff. The plan was that there would be two aircraft, this one to make the landing and another one to circle around and take photographs. But on the fateful day, the weather proved not so compatible and the other aircraft didn't develop enough power. So the two Intrepids took off. The two Intrepids were Leeming, the pilot, and a guy called Bert Hinkler, of whom you might have read, to take off. The pilot did not have the other aircraft to record the event, but he did have in the cockpit his little baby brownie box camera. And they managed to land. This photograph, taken with a little baby box camera, shows Bert Hinkler holding the aircraft against the breeze in the snow. And you can gauge the strength of the wind by the coat rim of the other gentleman in the picture. Now the other gentleman is very relevant. Remember, it was December in the Lakes District, and that's not the type of weather you have to go walking alone on a mountain. Only mad professors would do that. And it turned out that both the pilot, Leeming, and Hinkler were fortunate, A, that there was a lone person there who could witness it, and B, that he happened to be the professor of Greek of Birmingham University. And so they explained, well, the professor of Greek was astounded to see the aircraft land, and they were delighted to see that someone had witnessed it. And he obliged them by writing a confirmation of the event on a used hotel bill that he happened to have in his pocket. And it so happens, I believe it's still there to this day, there is a little plaque at the top of Helvellyn that records this event. Interestingly, it records that it was an Avro 504K, piloted by Leeming. Hinkler's name gets a mention, but Redrup, who designed and had built the engine that enabled it to operate, not a mention. The plane did take off. This obviously is a painting. And certainly it made history. Bert Hinkler, whom we've mentioned, he's perhaps the subject of another address. Quite an interesting pioneer in his own right. Another name, well known to Redrup and by Redrup, was Juan de la Cierva with his autogyros. I guess most of us have heard of Juan Cierva. Most of us have heard of autogyros, but nobody gets to know, that it was, a Redrup. Redrup with his alpha engine that was used. This is the Cierva on floats out of the experiments at the time. Then Redrup thought, why not develop an axial piston engine for an aircraft? In 1928, he develops this version called the Fury, 100 horsepower. And as you see, the cooling fins are not around the cylinders, but along the cylinders. One of the early installations of the Fury was a very interesting aircraft, the little home-built Spartan. It was designed with the aerodynamically beautiful front end that the radial that the negative that the axial cylinders allowed, and yet it was ideal for experimenting in the private airstrips at the time. This photo shows the Spartan prototype being gently refueled at the village. I think that's a lovely little historic photograph, including the registration plate at the tail end of the trailer, which is the front end of the aeroplane. Actually, Brian was able to let me know that WA had its own Spartan. Unfortunately, not with the Redrup engine that was owned and operated by Airlines, WA. And then Redrup decided to design and build an opposed piston engine. Now, you've, I hope, become aware of the axial piston engine, where the pistons go this way and you have the Z-shaped crankshaft, and so you can get power out. Imagine two of these brought together. No cylinder head, which reduces the weight. The two pistons are, if you like, clapping against each other. And so, with a design that included a wobble plate at the pointy end and another wobble plate at the rear end, he was able to draw 2,000 horsepower in 1936. This was a liquid-cooled design. As you can see there, you can see the liquid passage and also the cooling fins on the combustion chamber. And it was also an axial flow design. The larger exhaust port opened ahead of the inlet, obviously a two-stroke design, so that the supercharger could blow uniflow gas through the engine. This was in 1936, but also in 1936 there was another company designing another engine, Rolls-Royce. So this one didn't get into production. This gives you an idea of an opposed piston engine. This one is using a version of the swash plate, which is actually a cam drive. As the pistons move axially, the cam profile gives the output torque. And this shows the swash plate in a multi-cylinder design. And if you really want to see some complex design for getting torque out of an axial engine, have a look at this one. This one is using bevel gears to cause the crankshaft to rotate. And if you want a really complex mind boggler, imagine this not as a regular engine, but as a rotary engine. And I think that's enough. But in World War II, Redrup was still employed with Aero. And his record for the Lancaster was the design of a hydraulic pump and motor for the cannon drive, a winch for loading bombs into the aircraft, a hydraulic drive for the gun turret, and I think most significant of all, the bouncing bomb. We all have heard of Barnes-Wallis, we all know of the Lancaster attempt on the dams, but very few people have worried or thought about the fact that it was rotating as it fell. And the motor for this was Redrup's. In 1953, he was still alive, very active. He designed and built a 1,000 horsepower and a 2,000 axial Aero engine. This shows a block, cylinder block, of his design for the axial engine. I think you would agree with me that Charles Redrup was a very impressive man. Modest, but very impressive. And I hope that with this short PowerPoint, I've been able to introduce him to you and perhaps you to him. Thank you.